This SCEC-funded research evaluates high spatial resolution zircon helium thermochronometry as a fault-slip paleothermometer. The zircon helium system is sensitive to friction-generated heat produced during seismic slip, as shown by these zircon helium sensitivity contours falling within the earthquake duration box in this figure. We test this method at the Punchbowl Fault, where there is evidence of friction-generated heat using biomarker data. Our study shows general compatibility between biomarker and zircon helium systems, but the zircon helium system is not fully reset from friction-generated heat. This raises the question of the utility of zircon helium to identify these high temperatures in the rock record, and motivates us to test these methods on the West Salton Detachment Fault, where there is as much as 1 meter thick pseudotachyllite. Our ongoing work uses modeling and zircon helium analyses to explore temperature rise immediately after pseudotachyllite placement. Stop by our poster number 148 to check out our findings.